Good afternoon, everybody. Good afternoon, colleagues. Again, many thanks for joining us with this third e-dialogue. Let me just welcome and thanks colleagues from Aerofarms, Local Greens, Fluence, the Wageningen University and Research, and of course the European Bank for Development and Reconstruction. Please, Iride from the EBRD will give us a welcome speech. Iride, the floor is yours.
Thank you, Jacopo. Good afternoon, everybody. This is the third interactive e-dialogue, and it's a 9-party series. I'm Iride Ceccacci. I work for the European Bank for Reconstruction and Development in the agribusiness team. And together with the FAO, we are sponsoring this series of dialogues around topics related to urban farming. In the first 2 e-dialogues, more than 250 participants join us. So welcome back to those that actually were already with us in the previous 2. And welcome to the new joiners. As Jacopo was saying, we have distinguished speakers from companies, universities, and many experts in this room. I'm really impressed by the network of people that we are connecting to these e-dialogues. For us at the EBRD, this is an opportunity to look very closely at the sector, to understand which could be the challenges and the opportunities to provide advisory services or to invest in some of these opportunities. And today, our main topic is the technological transformation that this urban farming is bringing. So without further ado, I pass the floor to our speakers, and I wish all of us a very informative e-dialogue. Thank you, Jacopo.
Thank you, Iride. Many thanks. Again, many thanks to everybody for joining. Let me immediately give the floor to Professor Leo Marcellis from Wageningen Universities and Dr. Kusuma and Dr. Liu, that they will provide us with information and data. Leo, the floor is yours. Thank you very much.
Hey, thank you very much, Jacopo, and I'm very happy that I can moderate this session. I will not use much more words here, not to lose time, so that we stay within the time. I will. So we have 4 interesting speakers. There is room for questions about the talks at the end of the talks, but well, please use also the chat box already to ask your questions or make your remarks, and then at the end we will discuss some of them. If we don't have sufficient time for all of them, at least we can also respond in the chat box. And now I would not like to use more time, as I said, and give the word to my colleague, Paul Kusuma.
Okay, hello everyone. I am going to give a broad overview of the technology in urban farming, talking about the ways in which technology can reduce costs for players in this area, but also ways in which technology can increase yields and increase the quality of the produce. So on this last point of increasing yields, this is a graphic comparing yields of vertical farms compared to yields of a typical greenhouse production. And you can see here that a typical greenhouse has approximately, here in the Netherlands, about 40 kilograms of fresh mass per square meter per year. But we've done a few interviews with different vertical farms, and they've indicated that they can get anywhere between 1.5 to 6 times this number based on utilizing technology to optimize the environment for growth of the plants and increasing yields. So I'm hoping we can run a quick poll here. I'm still not seeing the option to run the poll. While we try to get this set up, the last thing I have to say about this is, despite the increase in yields that we're able to achieve in these systems, this does not mean that quality begins to suffer. In fact, it's quite the opposite. Vertical farms are well known for their high quality produce. This is high quality from the aspect of flavor and year-round reliable production. And because of this, the value from these urban farming systems are 1 to 3 times that of a typical greenhouse or outdoor system. Since this poll doesn't seem to be, here we go. So the poll is up now, and we're wondering where you line up on this yield data. So if you're willing and able to share, this will be an anonymous poll. And if we're unable to immediately show the results, it'll be included in our final report later. We'd like to know what kind of yields you're producing, especially in terms of lettuce. Are you getting 0 to 25 kilograms per square meter per year, 25 to 50, 50 to 75, 75 to 100, 100 to 200, or over 200 kilograms per square meter per year? I think maybe we'll just leave this poll open for now because there will be 2 more questions as I move through my presentation. So getting into the technology, we've outlined these 6 broad categories of technology in urban agriculture. And these are somewhat arbitrary categories, but it helps us to sort of think about the technologies in these specific sections. And I'll go through each of these briefly in the coming slides. So the first one here is lighting. We estimate that lighting is about 20 to 25% of a vertical farm's operational cost. So here's where the second poll comes in. We would like to know approximately what percent for you as growers, what percent of your daily operational cost is electricity? Is it less than 20%, 20 to 30%, 30 to 40%, 40 to 50%, or 50+%? We get the 20 to 25% by assuming electricity is about 30% of the operational cost, and then lighting is 70 to 80% of that. While people continue to answer this poll, I'll explain what we're looking at on this graph. This is showing the improvement in artificial lighting technology over the past 200 years. And what's especially noteworthy is the vast improvement in LED efficiency that we see all the way here on the right-hand side of the graph. Over the past 2 decades, the efficiency of LEDs has gone from around 10% all the way up to 70, 60 to 80%, somewhere in that region, to the point now where they're almost double the efficiency of the next best technology. And we expect to still see some improvements moving forward, but this will really decrease costs for the players in urban agriculture. The last thing I have to say about lighting is just to introduce our last speaker for today. It'll be a technology provider, Fluence Bioengineering. And there's a lot to do in urban agriculture with how you can manipulate spectrum to get optimal growth for your plants and really increase the quality of your product. So Fluence is going to talk a little bit about how they're providing technology to the sector so that the quality can increase. The next broad aspect of technology is the system. And by system, I'm talking a lot about the overall architecture, a lot of the hardware of the system. This refers to stacked shelving, as we can see here. Aerofarms, who will be the next speaker after me. They're the biggest vertical farm producer in the world. And it's no surprise that this has become sort of the picture people have in their minds for vertical farms. But the design of the overall architecture can have a big impact on how the efficiency of the overall system works, the growth, the resource utilization. And to put a note on this, we'll now highlight the last speaker, which is going to be Local Green. And they have taken a really new approach to how to think about the architecture of the system. They actually now, instead of growing on stacked layers, begin to grow in this vertical wall system. And this totally changes a lot of these other aspects of the environment. And it can play a big role in yields and, again, resource utilization. So a lot of these technologies are relatively new, and there's still a lot to be learned. The last thing I have to say about system is there's a really large initial investment cost. it's hard to say what exactly this is. It depends on the size of your farm. But we estimate that it's about 50% of the investment is the building and 50% is equipment. And this plays a large role in the role banks can play in the investment into urban agriculture, because there's this really high upfront cost. If you go back to your poll now, you'll see the final question on the poll is coming to this question of labor. What percent of labor is your typical daily operational cost? Here we've assumed come with an estimation of about 30%, but your numbers as our audience will be really good at giving us information on what it might actually be. So is it less than 10%, 10 to 20, 20 to 30, or more than 30%? The last thing to talk about on this slide is this image here, which is a harvesting robot. And there's a lot to be said about automated equipment in vertical farms, and they can play a big role in decreasing these labor costs for these systems, but it's also really big upfront investment cost. So hopefully we've gotten all the answers to the survey questions, so I think we can close that out. And now moving on to the next aspect of technology is root zones. There's a lot to be said about root zone technology. There are a lot of different types. You have multiple different types of hydroponic systems, aeroponic systems, and then in the greenhouse, you have a lot of media like peat, coconut coir, perlite, and vermiculite, as well as a lot of advancements in rock wool and stone wool technology. And these play a large role in optimizing the root zone so you get optimal shoot growth. With the urban environment setting, you can also do a lot of recycling of nutrients in these systems. So unlike field agriculture, where there's potentially a lot of runoff leading to something like eutrophication, which is a damaging process to the environment, we can recycle a lot of resources in these systems. However, there is something to be said about something like peat, which it's a good product for growing plants, but its long-term sustainability is questionable since it's a large carbon pool for the planet, and it's not necessarily rapidly reducible. So there's still a lot to be done on optimizing the root zone for growth. The next big category of technology is technology related to the climate. A big part of this is HVAC systems, which play a large role in cooling down high-tech greenhouses and vertical farms. And one of the nice things about HVAC systems is you can collect the water in the high humidity and recycle it back into the system. And because of this, these systems can use up to 95% less water compared to field production. And in talking with a lot of vertical farm producers, their goal is to get to the point where the only water leaving their facility is the water in the fresh weight of the vegetables and fruits that they're selling. When it comes to climate, another big aspect is changing around the CO2 concentration in the air. By enriching with CO2, you can get big increases in yield. This is a graph showing this in this image. Anywhere between 50 to 100% increase in yields from enriching with CO2. And it's a relatively inexpensive compared to some of these other technologies. So this is a big thing to do, but still a lot of optimization needs to be done. The last thing related to climate I want to touch on is if you have poor climate control, you can end up with an issue like we see here with tip burn. If you have a high humidity environment, this might inhibit transpiration in the plant and will lead to tip burn, and then your saleable produce goes down. So we still need to do a lot of work on improving the technology related to controlling the environment so we don't end up with issues like this. Closely connected with the climate is the sensors that are used to measure the climate. But when we talk about the technology of sensors, this isn't only sensors for measuring climate, but it's also imaging sensors for getting a good sense of how the plants are performing in the system. And in these high-tech environments, we can collect a whole lot of data. And then we use algorithms that use artificial intelligence and machine learning to optimize the overall system, both by decreasing inefficiency, so increasing efficiency, and increasing yields from these systems. So a whole lot is being done on sensor and data processing technology. The last aspect of technology that I want to touch on is genetics. So if we compare to the field production, a lot of breeding in the field is done to increase disease and pest resistance, and then deal with the high fluctuating environments of the outdoors. So plants need to be bred to be able to withstand high heat and really cold environments. But in a vertical farm and in a high-tech greenhouse, we can control these factors. So we can begin to start breeding plants for other factors like high harvest index or rapid growth cycles, but also things like quality. We can get really nutritious fruits and vegetables, really tasty fruits and vegetables. So now that we no longer have to focus on these other things, we can breed for this aspect of growth. So this has been a broad overview of the types of things that are being done for technology in the area of urban agriculture. And they're all highly linked with each other, but our speakers will go into more how technology has affected their business. We'd like to extend a special thank you to these companies who have helped us with interviews and gathering data for this report. And with that, I would like to pass it back to Leo.
Hey, thanks a lot, Paul. A very nice overview as a start of this meeting. As I said, if you have questions, raise your questions in the chat box. Maybe I can just pick one, but only very brief, because otherwise we would run out of time. Paul, initially you were talking about yields, and there was a question, is this the yield of one layer if there are stacked layers, or how is that?
The graph I showed was actually the results of not stacking. So you actually can increase yields even further on a per ground area basis by including the stacking into the system.
Does this also include square production values of where you have a vertical system, let's say what you showed where the plants are grown on a wall, or was that not included?
Those yes. So some of those have been provided to us, and it includes just the growing area of a single unit area of growth.
Okay, so thanks a lot, Paul. Very nice overview. I guess there will be more questions from the audience, so please write them in the chat. Then I guess Paul will also still have some time to answer, to write back, or we do them at the end. But now I would like to move on to the next speaker, and the next speaker is Stacy Kimmel. She's the Vice President of Research and Development of Aerofarms. Aerofarms, it was already mentioned earlier, a vertical farming company, very well known. So I'm very happy that Stacy is here to share some of her ideas and work they are doing. So Stacy, the floor is yours. And we see already your screen, so it seems all to work.
Great. Thank you, Leo, and appreciate the opportunity to speak today, and good morning, evening, afternoon to everyone, wherever you are. It's early here in the US. As Leo mentioned, I'm the Vice President of Research and Development at Aerofarms, and you saw a few pictures of our farm on Paul's presentation. I'll show you a few more things, but this morning I'm going to be focused on the slide, there we go, technology and how we think about technology in vertical farming and agriculture. So I'm going to cover a number of different areas throughout the presentation. I'll focus on things that we feel at Aerofarms are critical aspects of technology. Paul did a great job of summarizing generally, and I think you'll see a lot of synergies between what I say and what he had already spoken about, maybe more specifically related to our farm. But he's really got a lot of the things right there in the slide that he shared. I'll talk about the history of our farms a little bit and how we've advanced our technology over time since we've been in existence since 2004. Talk somewhat about our very, very large new farm that is under construction, will open later this year. Some partnerships around machine vision and drone usage in our farms to monitor plants. And then I'll talk about a few partnerships that are helping us really stay on the cutting edge of technology so that we're bringing forward the best we can into our system so that we can produce the best quality produce for our consumers. So I need to figure out how I need to get this off of, I still am seeing a few, there we go, a few pictures or a few videos. So I wanted to make sure my screen is clear so I can see everybody. So, you know, we've been innovating in vertical farming for many years. As I mentioned, we talked, I said we started in 2004 with what we call Model 1 farm. So in our world at Aerofarms, as Paul mentioned, the system, the design of the farm we call model. So our Model 1 was our very, very first farm in 2004, and we'll be implementing our latest technology in our Danville facility this year, which will be Model 5. So throughout the years, we've been continuing to improve our technology around design, lighting, automation, all kinds of things that are really important to continuing to drop the costs that we have and increase yield and improve quality. So we've been building farms for a number of years now. The picture that you saw on the first page is our Newark farm, which at the time it was built, and it still is, according to the Guinness Book of World Records, the largest vertical farm in the world. We built that in 2016, and we continue to add to that farm and have added over time to build around the farm, add ancillary equipment to reduce costs, improve automation, and improve output. And we continue to see improvements even with existing farms as we implement new technology. We are building a facility in Abu Dhabi, the UAE. We'll start growing plants only a few months from now. It will be the largest research facility in the world focused on vertical farming. So this will be where we're thinking about how do we advance the technology faster. We're going to be focusing on a number of areas in that facility, some of which you'll hear about, and others related to particular partners that are interested in trying to think about how we might use vertical farming and the platform that Aerofarms has to increase sustainability, to think about how to have more secure supply chain, food security in areas where food is scarce and often imported. So that research facility will be doing a lot of that work and will open this year. So there's a picture here of our Danville farm, but I'll talk a little bit more about that in future slides. So as I mentioned, we have a number of things that we talk about internally that are very critical to us. So, you know, there's a lot of things that you could focus on relative to a farm inside, and we think about some of those things, but not all of those things. So this slide really covers the things that we think about that are critical to us, the things that we want to own, the things we want to be the best at. Over the 15 years, we've continued to evolve through multiple generations, continuing to de-risk components of our farm, reducing costs. These are the areas that we focus on when we think about how we want to do that. So over the years, we have improvements in technology that allowed us to drop our cost of goods sold by 70 to 80% since we started in 2004. And we're going to continue to do that with every model farm as we improve. So we talked a little bit about the grow towers earlier. We use aeroponic technology. This technology allows our roots to receive optimal amount of nutrients, water, and oxygen. The roots sit below a proprietary cloth medium that we have invented. It is reusable and recyclable. The seeds germinate, the roots go down through the cloth, and the biomass of the plant, the green part of the plant, goes up towards the light and grows up towards the light. So the roots are misted very lightly with water, so they're not sitting in water. They get just the amount of water that they need. And the water beads on the roots nicely, and we're able to use a lot less water just by misting versus having the roots sitting in water. So this aeroponics system also is attached to an automated nutrient delivery system, which we have designed specifically for our farms. It allows us to deliver whatever recipe of nutrients that we want to deliver to the root system, depending on the type of variety that we're growing, the cycle of growing, the duration of the growing. All those things come into play when we think about what the delivery of the nutrients would be. Genetics, Paul talked about, we have, we think about optimizing variety, and we have a number of things that we are looking at. I'll talk a little bit about those. Think about what is the best type of variety for an indoor farm. There's a lot of varieties out there that have been bred for outside farming. How do we think about genetics for indoor farming, and what are the best genetics for indoor farming? We're automating wherever we can. We have HVAC is a big aspect of our cost, but also of our focus on design. LEDs have been mentioned, and we have unique horticulture luminaire technology. Our CTO, Roger Bulow, has a long history in lighting technology, and we have custom lights that we use that are proprietary to us in our farms. We have we use machine vision and drones. I'll talk a little bit about that more. We have very high quality systems and operating procedures in our farms to maintain food safety and quality. And then along with the machine vision, I'll talk a little bit about our digital controls, our algorithms, and our software that helps us integrate all this and manage our data. So this is a bigger picture of our new farm in Danville, Virginia. We had a huge hiring event this week, actually. So we're hiring over 100 people to work in this facility in Virginia. This will be our latest and greatest technology, and it will have unprecedented environmental control. We've been demonstrating production of plants at scale for many years. This facility is 4 times as large as the facility in Newark. It will have 4 times the capacity. So it's very big. It's expansive. It's very difficult to explain how big it is until you walk in there, but it is very large. And the way that we continue to do this is through my team, which I lead, which is the R&D team, managing to stay ahead of what's happening and bringing technology into our facilities. We partner with the USDA, with FAO. We have a project called the Precision Indoor Plants Consortium, which I'll talk a little bit about relative to how do we get plants specifically for indoor farms, and the Abu Dhabi Research Center, which I already talked about. So we have a partnership, active partnership now with Nokia Bell Labs, looking at implementing machine vision to monitor plant health in large scale farms. So if you imagine in a farm 4 times the size of our Newark farm, it's a lot of towers, a lot of growing. So humans having to keep their eyeballs on all of those plants is pretty hard to imagine how that could be possible. Even if you had a lot of people, it's probably not realistic. So the idea of, as these farms get bigger, using drones to capture images of the plants and then processing those images through with machine vision technology allows us to really pinpoint where the issues are in the farm. So if you've got this big farm, you've got a grower that comes in the morning, the images have been captured through the night. They're able to really focus their attention on places where something might be not necessarily looking as good as it should. And we can troubleshoot. There might be something actually really interesting happening that we want to pay attention to that could be give us some more information about how we might think about future research. And all of that, we're looping back and making sure that we're using that information to make sure we're managing issues in the farm, but also we're capturing new information that could help us understand what's going on that we can explore further and potentially bring back to the farm. So we think about, these drones would be capturing how is the canopy looking? What's the coverage of the canopy? What is the color of the plant? Do we have spotting? Do we have browning? Are the edges growing? Do we have areas inside the tower where we have some lower growth than others? And that way the grower can really focus where his or her attention where it needs to be focused, as opposed to having to look at every single plant every single day. It's just too much as these farms get bigger. We need this technology to be able to operate efficiently and effectively and to learn. So a lot of how we stay close to what's happening in technology is to stay close with some of the top agricultural universities in the world. Wageningen, we have a number of representatives here on this session from their terrific university that we're working with now, related to the Precision Indoor Plants Consortium. They're doing some studies for us on lettuce, strawberries, and tomatoes. We are members of Blaze and LAMP to make sure that we're staying abreast of the latest research. And these things in a new industry, you have to figure out where are you going to find the most interesting work that's happening so that you can think about how to apply it. I came from big CPG, and universities were not a big part of what we did in our research setups, because we had been working for 150 years with technology, similar technology. There wasn't really a ton to learn more other than what we would learn internally about how we were doing things, which was very proprietary. In this industry, it's very different. Everybody is still learning, and there's a lot to be gained from staying close to folks in academia that are doing some of the best research in the area, and how do we apply it back to our farms. So this is a slide about the Precision Indoor Plants Consortium that I have mentioned a couple of times. This is a consortium of non-competitive companies. Fluence, who you'll hear speak in a few minutes, they are part of this consortium. There's a number of other technology companies, breeding companies, and dosing system companies that are involved in this. And the intent really is to think about how do we adapt crops to grow in indoor environments. So as Paul mentioned, we've got a lot of plants that have been bred for outdoors. So what about indoors? What do we want to be growing indoors specifically? And is it the same type of plant? Should it be? Are there aspects of it that should be similar, and there are aspects of it that may need to be different to help to just deal with what's happening inside versus outside and give us the best quality and best yields that we can. So the focus of this consortium initially is on lettuce. So we've been doing this work now for about 2 years, I want to say. The focus on lettuce is about browning, and how do you accelerate growth of lettuce without tip burn, which Paul also mentioned. So future studies within this consortium will focus on strawberries and tomatoes. In terms of strawberries and tomatoes, we think about what are the types of flavors that we can get inside that we are unable to get outdoors? What type of architecture, plant architecture makes sense for indoor farms? Tomatoes many of them are tall, and they need to be staked, and they take a lot of space to grow. Are there different ways to breed tomatoes where the architecture is more suitable for indoor farming, but is producing the same amount of fruit? So we just announced that project for tomatoes, and we will be working on strawberries as well, looking at premium flavor. The last thing I'll mention about this consortium, which is a pretty interesting aspect of it, is that we're thinking about how do we use the vertical farming platform for breeding. So we talk a lot about using vertical farming to grow produce that we then sell to consumers, which is certainly great, but how do we use the technology to do different things to solve problems in agriculture? Breeding is a very long process. So is there a way to use the indoor farm to accelerate the breeding process? And we've been doing that work with this consortium. actually doing breeding in an indoor farm and thinking about how might we use this platform differently than just producing produce. So if you think end to end, how could you use a vertical farm? And there's a lot of ways to think about that, not just the produce itself, but all along the value chain. Where could we add where could we insert this technology to help overall solving problems in agriculture? And breeding is one of those areas that we've been looking at. So last slide, you know what, just to make everybody clear, there's a lot of folks on this call. We are very interested in partnerships. We have a lot of partnerships now. As I mentioned, it's critical to us to be able to advance our technology. And there are things that we want to own and we want to build ourselves, but there are things that other people do better than us, or maybe working with us could improve. So we make decisions about where we want to own our technology and where we want to buy it or partner. And we do this regularly to make sure that we're hitting all aspects, because you can't be everything. You have to focus only on the things that are critical. So we're focused on leafy greens. We're focusing quite a bit now on strawberries. You're hearing a lot in the news about strawberries right now, and indoor farming and vertical farming. High value nurseries is another aspect of what I mentioned regarding speed breeding. How might we think about our platform differently, right? So it's not just for producing food. What other things can we do in the agricultural end-to-end chain where we can bring value? Nursery might be another way to do that. We can bring clean plant material that's never been exposed to any outdoor virus or pest or fungus. We can bring that to a greenhouse, to a field farmer, all those types of things you could use this platform for. We can think about it relative to climate change and how do we produce produce for communities. We've just launched a community farm program in New Jersey, and we have a small farm unit that we're putting in a number of locations around the city so that individuals can learn and see how crops are grown, but also use that produce and take it home to eat. So on the right-hand side, just a few crops that we're exploring and other things that we're interested in relative to technology. So tunable lighting, obviously that's something that's, if you think about the nutrient recipes that we have, being able to have a very specific light recipe where you might have a certain spectrum for part of the growing period, another spectrum for another part of the growing period. This is beyond just photo period generally. It's about what type of spectrum for what type of part of the growing cycle do you want to have for the plants. AI and machine learning. Many of these plants that we're thinking about for the future require pollination. How do you do pollination inside? Do you use bees? Maybe. Harvest automation. There's a lot of labor involved in harvesting some of these plants. Do you do that? Can you do that with machines and robots? And then how do you...
We're running out of time, so I guess this is...
I'm finished.
So please.
Yeah, this is it. I'm done. Go ahead.
Okay, great. Well, very impressive presentation. Very nice. There are a number of questions popping up in the chat box. I would say that most of it, I hope you have some time that you can answer them. Maybe you can do one question, if it's possible, very briefly. So you indicated this very impressive, I think, cost reduction by 70 to 80%. Can you give us an idea? What do you expect for the coming 3 to 5 years? How much further that can be reduced?
Yeah, I mean, I think it's hard to put an exact number on that until as we're thinking through what we want to put in play. I think our LEDs are always a focus area for us. So as we think about energy usage, we continue to look at our LED technology as a target for reduction of cost of goods. We have, as I mentioned, our model farm designs are becoming more and more efficient. So I think, a lot of what I talked about, those areas are going to continue to be a focus and help us reduce our cost of goods. Can I put an exact number on it? Probably not at this point. We haven't even opened the farm, the next model farm. When we do, perhaps we'll have a better handle on it. But we'll be looking at a lot of the same suspects that we've already spoken about.
Okay. Good. Well, it would be nice to, if you have some time to further talk about it. I hope you still have some time, Stacey, to have a look at, because there are a number of questions in the chat box, and maybe in the audience there are even more questions. So please write them in the chat box, and I hope we can answer them. But because otherwise we would run out of time. So Stacey, once again, thanks a lot for your very nice contribution. Really excellent to hear. And then I would like to immediately move on to the next speaker. The next speaker is Marco Maggioni, and he is of Local Greens, which is a startup company in vertical farming business. So very happy, Marco, that you are here, and I would like to give the floor to you.
Hi everyone. So yeah, this is Marco. I want to really thank Jacopo, Ying, Paul, Leo for inviting me. Thanks to FAO, EBRD. It's a great honor to speak along with the big dogs from Aerofarms Influence. I think that this industry exists because of that, and I have learned a lot from their groundbreaking technology, right? We are speaking about Local Green today. So the team is the leading team. It's me. I'm the head of R&D. I'm in charge of all the R&D operation and scientific direction of Local Green. Paolo and Lorenzo are the two founders. Lorenzo is our engineer, our CTO, and Paolo is our CFO. We're all very young, and the company it's still at the beginning, but we're doing pretty well. We started in 2019. Our history it's quite short, but we had some fundings and some R&D partnership, especially with Neural Hub, which provided us the offices and also the space where to install our first growth chamber. We are currently building our first plant factory. That will be operational in June, maybe July. Yeah, there are some delays due to the ongoing situation in Europe. In 2023, we are going to start to deploy new modules and design a new facility.
Marco, you're not sharing your screen at the moment.
Yeah.
Sorry. There is something. Is it?
Yes, now we see it, Marco.
I'm sorry, guys. So yeah, these are the two guys before, and this is our timeline. And yeah, so we have already some achievements. So we are already on the shelf because we are already selling to the actually biggest retailer in Italy. It's Coop. And we got a quote from Francesco, which is here also, as one of the main players in the vertical farming industry in Italy. And so it was an achievement for us. And quickly going to where are we coming from? We are radically changing the approach of vertical farming. So what does it mean? There is an ongoing discussion of where vertical farming is going toward. Thanks to Paul and Leo, we already spoke about a lot of things that are fundamental in the vertical farming conundrum, profitability, right? So we identified three main pillars in the viability of vertical farming, which are capitals, operational costs, and productivity. So we think that an intelligent use of capital, so a better design of the plant factory, can play a fundamental role in the profitability plan of a startup, a vertical farming startup. And the design is fundamental also in reducing OpEx, so reducing labor cost and reducing electricity usage, right? So another topic that it's ongoing, it's productivity. So increase crop productivity. It's also a very important way to increase profitability of the vertical farm. So our technology, we think that the key elements of profitability regarding the capital and therefore the infrastructure are modularity. So we think that in order to cut the cost, especially the design cost, it's very clever to design modules, because you can enhance your profitability reducing the design cost and putting them upfront instead of distributing them and designing your vertical farm for each of every facility you're going to. And the other pillar is the automation. So automation, especially in Europe, but also in the US, is fundamental in reducing the labor cost. So here we see a vertical farm that is like as we think. So this big, like Stacy was speaking about, like these growing towers. The plants and the trays usually stay where they are, and operators have to go towards the plants with scissor lift or other system. Those systems have like a relatively low capex, but they have very high operational costs due to the fact that operators need to spend a lot of time going towards the plant. So we think that this particular technology for automation is very intelligent. It's called overhead conveyors. As you can see, like some players are already using it. In these photos, there is plenty. There's also a vertical farm in the US and Lusgarda in Sweden. They are using this automation to move plants toward the operators or towards the operation centers, like harvesting, seeding, you name it. And we think this technology is very clever because it's cheap, it's reliable, which is very important, and it has low maintenance because historically it's already used in the food industry, and it's food grade, therefore. And also, this technology can perform very well in a vertical farming environment, such as a high humidity environment, typical of the vertical farm. Another big advantage and a radical approach of local green is the fact that heat removal, it's still an ongoing problem in all the stacked system. This has two main disadvantages: higher capital needed to design the heat removal technology. It requires very high skilled engineers, like thermofluid dynamics engineer and so on. And so we think that vertical system might respond to this question: how to effectively and in a cheap way remove heat and latent heat from the leaf canopy. We know that like not removing it has problems with tip burns and pathogen proliferation, you name it, a lot of problems. Another thing we are focusing on is the agricultural practices and genetics. Stacy already spoke about a lot, like collaboration with breeders. We are also collaborating with an Italian breeder in order to develop like genetic specifically made for vertical farms. It's a super interesting topic. We are not working yet with fruity crops, but we will. What we are focusing on are multi-leaf lettuces. So in this photo, you see a full head of lettuce, a multi-leaf lettuce, in this case Salanova. Those heads are usually grown at low density, so between 40 and 80 plants per square meters. We are using an agronomical technique to reduce the size of the head. So we're actually growing very small head because they're between 25 and 35 grams per head, but at very high density. And we're growing them with a specific light spectrum and a specific light intensity in order to have a very small leaf, which is the standard for the ready-to-eat produce in Italy. In this way, we estimate that a traditional genetic used in vertical farming can produce between 50 and 60 kilos per square meters per year. In this way, we already achieved with a 1.1, 1.2 recipe more than 100 kilos per square meter per year. And considering not the projected surface, but the actual cultivation surface. So pretty good results for such a young company. We also focused a lot on other agronomical practices, such as irrigation. Stacy already spoke about like the advantages of using aeroponics. We think that aeroponic has some very good advantages. Increase water use efficiencies. So this means less like expenses for the humidification, higher productivity, the fact that you can use like less medium or no medium. So reducing, cleaning and the risk, mitigation of risk of plants pathogen. Aeroponic brings a lot of drawbacks though, like high capital investment and high operational costs. Seems to be banal, but aeroponics traditional, let's say aeroponic system requires a lot of nozzles, a lot of pipes, and these pipes and nozzles often clogs themselves. It seems to be a banal problem, but it's not. In this photo, we are not showing our proprietary technology aeroponic system, since is not the patent is still pending, but I can say that we reduced up to 95% the number of nozzles and the number of pipes, and in this way we reduce greatly the capital and the operational costs. I want to also, address that with this system, we have a humanless growth environment because it's fully automated. And to me, this is a great advantage of fully automated systems because, foodborne illnesses and plant pathogens vectors are usually humans. Also, our system is fully modular, so can be installed in a building, whatsoever building in whatever part of the world. And it's based on overhead conveyor systems, which are food grade and cheap. So we centralize operation, we reduce labor costs, which it's very expensive in Western countries. And we use aeroponics, so we have like very high yield. Some words about like the unit labor costs. So our system is pretty flexible. It is adaptable to different degree of automation. So we can install and basically scale our system with different degree of automation, a low automation, a medium automation, and a high automation. And this directly impacts the cost, the capital, the capital investment for the system. So basically, we estimate that right now we are building, as you can see here, the first module, which is 1,500 square meters. We can build already only with one module a way cheaper technology compared to traditional vertical farms. And this cost like dramatically reduce with 2 units or 3 units, because basically the growing unit just grow the plants, but the automation is the same for we share the automation with the 3 modules. And also we share, all the machines to do the operation, like harvesting, seeding, packaging, you name it. So next steps, what we are working on. So we just hired 2 new employees. Filippo is also like a crop scientist. Also, he was also working in Inform with me as a friend of mine, and he just joined 1 month ago. And also we hired Paolo. Paolo is another crop scientist, actually from Wageningen University, is our junior agronomist. And we are working with a lot of things that Stacy was speaking about. So crop modeling, especially, and high throughput measurements. Why we're doing that? Because when you spend a lot of money on R&D in order to, do this type of research, we think you need to have a practical goal. So the goal of like building like crop models is not only to monitor the plants, but is to tune the inputs, the energetic inputs, especially in order to achieve different results. Why we're doing that? Because we want to further minimize our operational costs, which are coming a lot from electricity costs. So we all love renewable energies like solar and wind. So we are trying to integrate vertical farming systems in the demand response mechanism. What is demand response? Basically, a long story short, renewable energies such as wind and solar produce energy, so they have like peaks of production when there is basically low demand for energy. And this gives like a great instability in the grid. And the grid is performing well and is not under danger when there is a balance between energy supply and energy demand. Vertical farms can play a big role in this, because tuning their electricity consumption, so absorbing more electricity when there is an overproduction, or decreasing their energy consumption when there is a high demand, and collaborating with demand response providers. Those demand response providers pay you to do that, and this can be another revenue stream for a vertical farm, and also a great advantage for the national grid itself. So we are developing them right now. We have all the tools to do that, and we think it's a great model to further develop our technology and to increase our profitability. Another, so as you can see here, some similar technologies are already in use in commercial greenhouses. We think that our technology can be adapted also to different scenarios, different degree of technology, as well as in greenhouses, also in countries where maybe vertical farms don't make sense. And so it's also a way to scale our technology in other contexts. So some takeaways from this presentation is that, like, we think, and I personally think, that technology plays a crucial role in the urban farming industry, and technology is a tool to reduce capital and operational costs. And the fact that local greens technology will contribute to, we are sure that we will contribute to the development of urban farming in Europe and across the world, because local green technology is flexible. And yeah, this was my presentation. If you guys have some other questions, otherwise I leave the words to Leo. Thank you very much to everybody.
Okay, thanks a lot, Marco. Very stimulating to hear all what you are doing. It's very exciting. Because we are running out of time, I suggest that we do the questions through the chat box. So please, Marco, there are already a number of questions about the square meters used, how do you define the square meter, what sensors are you using in the crop? So you see there's a lot of interest that people would like to know more. I hope you can write some answers in the chat box, and maybe people have some more questions, but because otherwise we would run out of time, I will now immediately go on to the next speaker. So thanks again, Marco. And now as the last speakers, well, the last speaker are in fact two speakers of Fluence Bioengineering, a lighting company, and that will be FAO Textra and Harris Ozunes. So they will do a joint presentation, and I guess that FAO is the first one to start. Am I correct?
Yes, that is correct. Thank you, Leo. Good morning, afternoon, or evening, everyone. My name is Theo Textra. I'm the technical director of Fluence EMEA. I'm strategically responsible for our technical pillar within the company. So I'm also responsible for facilitating research within EMEA and driving product development based on research results and developments in the market. I'm with Fluence now for almost 3 years, and previously I worked as international marketing manager and product marketing manager for Cavita for 9 years, where I drove, for example, the professionalization of lighting in the cannabis industry. Over to Harris.
Good morning, good afternoon also from my side. My name is Harris Ozunes, and I'm working for the research team of Fluence in EMEA for a bit more than 4 years. My background is plant photobiology, so I have worked on the effects of LED lighting in different crops the last decade of my life, I would say. I also had a chance to do my postdoc at Wageningen University together with Lemar Marcellus, and specifically on tomatoes. And now I'm currently researching spectral and intensity effects mainly on vine crops, strawberries, but also other crops that can be in the vertical farm section. So Theo, back to you.
Thank you, Harris. Well, I don't think we need to explain the big picture anymore, right? You all know the advantage of vertical farming. However, there's always one big elephant in the room, and that is the environmental impact. And until now, and it was mentioned in a previous webinar in this series already, transporting a head of lettuce from Salina to New York is still cheaper than growing it locally. So we will have to reduce costs due to energy use and also reduce environmental impact. At this moment, even greenhouse growers turn off their lights or abandon crops because of high energy and gas prices. So energy is a big issue. Leo, a few years ago, we had a Vertifarm conference in Wageningen, and it was very inspiring and innovation driven, but the last speaker basically stated that he didn't see any business case because of the extremely high energy costs compared to greenhouse crops. Delft University had the same remarks last year at Green Tech during their presentation regarding the energy cost, basically. However, we do see that there are niches and viable applications already, and there's a way forward which we were going to discuss next. I don't foresee us grow field crops like corn or wheat indoors on short term on a massive scale. So we're not going to completely feed the world with vertical farming only, but it's extremely suitable, for example, short cycle crops, leafy greens, herbs, and also grow those in places where you wouldn't normally be able to grow foods, like in food deserts, polar areas, or even a desert. Growing safe food, of course, is also a big concern. If you look at areas, for example, Fukushima, and we all know the impact of salmonella outbreaks in field-grown crops, which often happen at this moment, of course, in North America, where we see many reports about that. Field safety becomes more of an issue. As for local, there are many opportunities in food deserts or areas where there's a strong connection to local food production. For example, in Sweden, consumers, even in the winter, are prepared to pay a higher price for a locally grown quality cucumber instead of an imported Spanish one. So there's local niches as well. But of course, high-value crops such as strawberries, berries were named previously, are very suitable for vertical farming. And let's not forget medical crops. Cannabis is a good example, where vertical farming is currently already profitable and applied in large-scale facilities successfully worldwide. Another example of a medical crop could, for example, be Artemisia, to grow malaria medicines in order to enable communities to locally become self-sufficient for their medicine production. Currently, though, the consumer needs to be prepared to pay a higher price, and of course, we need to further reduce environmental impact due to energy use. There is a road ahead, though, in our opinion, and Harris is going to be touching some of the directions in the next slide.
Thank you, Theo. So in this slide, I'm going to talk about some parameters that you should take into account when you want to invest in vertical farms and think about how to make indoor farm systems more efficient in terms of cost, or else what are the challenges and what to think or to downscale these costs. In this case, mostly about your operational expenses that can lead to a cost reduction. So 3 pillars that we see here to play a major role. If you're going to tackle the labor costs mainly, you have to include automation, as also Marco mentioned that. If all the processes are done with automation at the end, that will reduce also your labor cost. Second, you want to think about less energy input possible, of course, in your system, with the recycling, for example, of your water, your nutrients, but also residual heat or CO2. This way, your energy input will be less. And by doing so, with this circular reuse of energy, you also reduce the environmental impact as well. And third, you can think also about efficient lighting systems. Light is probably one of the biggest costs, but running those systems can become more efficient if you choose efficient lighting. There you have spectral choices, of course, that can range from a very efficient red-blue spectrum to a broader white, but it will be less efficient spectrum. But by saying that, you have to think also what kind of crops you will be growing. If you don't have a monoculture and you grow multiple crops or you switch crops, you're better off maybe with a broader spectrum. As we have seen that crops are not all responding well under narrowband spectra, but you can think also about photoacclimation, for example. You can start with white light and finish with a quite high blue portion in your spectrum that can increase the anthocyanin content, similar to what Stacy mentioned in the beginning. And we've seen this also in the greenhouses from our customers. And in addition, you can also think of the cultivar dependence, which you need to take into account, and you might consider, for example, a broader spectrum in that case. Which brings me to the next point about the breeding programs that are being established now or will be established in the next years. Already mentioned by Stacy here also that breeders should create cultivars that are suitable for vertical farming conditions, that is clear, but also suitable for the most efficient lighting, which is obviously at this moment a red-blue narrow spectrum. So basic plants that are able to make or create plants that are able to withstand any kind of spectrum and grow well under the most efficient lightings. Of course, though, you can breed for, you can choose for what you're going to breed, for flavor, for taste, for against diseases, to make robust crops, for example. And at the end, the companies also this way can create IP out of those, which is an important factor if you can take into account in the whole investment. But breeding for efficient lighting is quite crucial. There are already efforts towards that, like PIP or FAO consortia that is already mentioned. Moving now to the knowledge pillar, it is clear that you need to have enough understanding and background knowledge. So there is a shortage of cultivation knowledge still in this field. There is lack of plant scientists or cultivation managers who are, let's say, experts in growing in such systems, but they have autonomous growing and artificial intelligence that they generate the data, and they need to be interpreted in a specific way, in the right way. Therefore, for the successful large-scale rollout, you need cultivation managers. In less developed countries or remote, for example, you need the autonomous growing, and then you can grow an excellent crop even without a local expert cultivator. And this all to say that you need the system to be knowledge independent as much as possible, if I may say that. So think of, for example, that you want to grow the Artemisia in Africa for malaria, as Theo mentioned, then you will need someone with expertise to show you grow that unless you have also the automation. And we should not also forget about the market readiness here. We used to say local, but the word local can have more than one meaning. So local as in local situation where the consumer needs to be ready. The consumer should be able to pay a higher price for the product, and he or she needs to be informed in order to do that selection. So the consumer should also be educated about the vertical farming approach and the indoor farming and why that food is better, is safer, is more nutritious, etc. So think about the community outreach as well that can bring people closer to growing. And how to do that? Second, local, as in local cost differences. Of course, from place to place, the labor can be cheaper or more expensive. But if you have a cheap labor, maybe it is better to do that instead of going to automation. So that it depends also where you are. And if energy prices can differ, then the business model is different. For example, you have solar panels in the United Arab Emirates, and you have a lot of solar light, you should definitely take into account the solar energy, right? So for your system usage, something that probably you'll not be able to do this in Finland or North Sweden, etc. And third, as in local demand, for example, you could have food shortages in some places or in some periods of the year, or if you are, for example, in a food desert, and if you cannot bring the food there otherwise, there, for example, like think of Antarctica, that there's no sun or no heat, or in places that you can even build greenhouses, for example, then in those cases should be considered as well. And with that, back to Theo.
Thank you. Let's switch to something completely different, because whether you grow in a vertical farm or in a greenhouse, one of the biggest success factors in any grow is healthy starting material. But there's already a great case to be made for vertical propagation of plant material. And here we don't only talk about lettuce and herbs, but basically any starting material. It's another application of vertical farming that is often overlooked in discussion, but already rolled out widely across the industry, and it is economically viable already. It's part of full cycle vertical farming, of course, but also utilizing greenhouse environments to be able to compete in quality, flexibility of production, reduce infestations, and also reduce environmental footprint due to transportation. So I call it the other vertical. There are many attributes of propagation that make it ideally suited for vertical farming. First, the high plant density of the small plants and the multi-layered utilization of space frees up greenhouse space for production. Secondly, full control of all limiting factors results in an optimal plant quality, plant resilience, and consistency year-round, which is a critical success factor in any cultivation process. By keeping propagation in-house, you have full control of IPM as well, which can be an issue with third-party materials. And then eliminating transportation reduces your carbon footprint, your shrink, your plant stress, and transplantation shock. In many pictures in this presentation, and also in the Aerofarm presentation, you see that customers use a broad spectrum. Though it's not the most efficient of light spectrums, there are many advantages in CapEx as well as application of broad spectrum light that make it the spectrum of choice for many growers. So we want to elaborate a bit more on that, not only for propagation, but also for vertical farming. And Harris will elaborate on these aspects. Harris.
Yeah. So here I wanted to briefly touch on the subject of the broad spectrum advantages. Again, we should always, of course, think in terms of efficiency and light efficacy. But when it comes to the propagation, this should not matter, let's say, a lot. In those cases, you have a relatively short cycle, or maybe a few weeks. You're using low intensity also in your system, so low PPFD levels. Then the broader spectrum is okay to use. But thinking also of the amount of energy used per plant, so small plants at high densities. Also, Marco mentioned that already. This can add to lower energy impact because in such space you can use more plants. Therefore, you win that way. In addition, your lighting systems with a broader spectrum will be more flexible. I already mentioned that some cultivars are not responding well to all spectra. And if you want to grow, for example, different cultivars or different species, the broader spectrum gives you more flexibility in that way. And also something to consider is the plant structure here. From the literature, we know that the broad spectrum, for example, that has high blue content, is creating strong and healthy root systems. And if you think also of the transition from your propagation site to your greenhouse site, so from a propagation phase where you use a broad spectrum to the greenhouse that you might depend on solar light, a broader spectrum there is a smoother transition for the plant. It is not yet clear, let's say, how this photoacclimation with very different spectra can affect that plant development, but it's definitely something worth researching on. But all in all, you can have a lower transplant shock due to similar spectral acclimation, or at least you don't risk that phase that much. And with that, back to Theo for finalizing.
Yes, we would like to conclude this short presentation with a few commercial examples. What you see here is Bowery farming in New York, a highly automated vertical farm. And basically, as you can see, they use a broad spectrum to enable them to grow a wide variety of different crops and cultivars. Second example, ECF Farm Systems. They develop aquaponic systems and they grow local for local organic basil in their aquaponics greenhouse in the center of Berlin. To reduce the effects of transportation, increase quality, control IPM, and be flexible in changing market demands, they insource propagation. Last but not least, you saw a few pictures of them already, and behind me, Shenandoah Growers, who is the largest organic herb producer in the United States, switched from greenhouse propagation to vertical propagation in order to free up greenhouse space for production and to have optimal control of starting material year-round. And they're actually moving to full cycle indoor growing as well in vertical farming. With that, I thank you for your attention, and we'll leave some extra time for questions actually.
Okay, really great, Theo and Harris. Very nice overview. Nice to see what we can do with Live, but also that you think a little bit further than only Live, because in the end it's many things. So thanks a lot for sharing that with us and for staying within the time. So there's still some time for questions to this presentation. Do not directly see questions yet to your presentation in the chat, but maybe they still come up. Maybe I can do also, well, one question to you, but maybe also to other presenters. But in your presentation, you also briefly indicated different countries, and in particular also for developing countries. So is vertical farming, is it now only something, let's say, for the richer countries, or is it also for, well, the less rich or developing countries?
That's an excellent question, because, you know, this is one of the reasons why we're here. How can we reduce cost, right? I mean, it's not only capex, though capex is really important, it's also opex. And again, a lot of the less developed countries are very sunny countries actually, which is an advantage if you want to generate energy, of course. We discuss labor, of course, as an input. If you have cheap labor, you can reduce capex by actually using labor instead of automation. But we think one of the key elements in making vertical farming a success in less developed countries is artificial intelligence and autonomous growing, basically. Having the automation available to take out the knowledge aspect that you need, the local cultivation knowledge, in order to make your grow a success.
Okay. Maybe also some of the Stacy or Marco, would you like to respond to this? Or?
Yeah, for sure. I mean, can you hear me, right?
Yes.
Yeah, I think that all the technology with different degree of automation can respond also to developing countries market. As the guys were saying, you can substitute automation with labor, which is cheaper in other part of the world, and maybe automation is more expensive. So of course, like specifically regarding local greens technology, we think that is like a winner in Italy and in Europe, but probably when you're going to other part of the world, this cannot be, and this shouldn't be the solution for those specific markets. So you need to have different approach to the vertical farming in order to, you know, scale in other parts of the world. But yeah, definitely, if the answer is yes, yeah, I think that it can be adopted by also developing countries.
Great. Stacy, did you also want to, I think you also started to respond to this. Did I see that correctly?
Yeah, sure. I mean, I think
just keep it briefly. Yes.
Yeah, the other panelists have really made some good comments. I think the one thing about other countries is thinking about the types of crops that could be useful in other parts of the world. They may not be similar to what we're currently able to grow very effectively in vertical farms. So there's opportunity there to think about local crops and what makes sense and what the economics of those types of crops are, not just the farm itself and the economics of the farm, but what types of food do people in different parts of the world really want from a vertical farm.
Then maybe another general question. What we see in the vertical farming is there are a lot of investments. So there are investors, there are banks. I don't know so much about that, but how important is the role of banks and investors in, let's say, in moving the vertical farming sector forward? Does anybody of the speakers want to respond to that?
Yeah, I think, but it's also the way you, not only the way of financing, but the way you offer your product as well. For example, now we have to buy our products to use them, but you could use, for example, different strategies such as lighting as a service, where you do not sell the lighting anymore, but basically you give them the lighting and they only pay for the light that they use. So efficiency and different business models may come in place there.
Yeah. Okay. Anyone of the others want to respond?
Yeah, I think it's interesting to think about, to build on Theo's comments. What types of things can you use a vertical farm for? And there's more ways to be profitable than just selling produce potentially. So, and those types of aspects, the broader thinking around the vertical farming platform, I think brings in a lot of interest from folks who are interested in looking at financing, because they see a bigger picture opportunity than just what is currently available. There's a big runway here. It just depends on where you want to take it. And there's lots of ways you could go. And every company that's in this business now, we're all selling leafy greens, but I think we'll eventually diverge at some point, potentially to do either sell different products or sell parts of our platforms or other types of ways to think about the business than are currently obvious today.
Okay, yeah, and also, Leo, in these banks, and they have to, all the financial pursuers, they have to understand that this is not going to be a return on investment. It will be like in a 6 months, let's say, or in a year. It will take time for all these aspects to, for example, from breeding, varieties and all this, that it will take more, way more years than expected in traditional, for example, agriculture to have an ROI or return on investment. So they probably have to understand that and the long run, as Stacey just mentioned.
Okay, thanks a lot. By the way, Theo, can you stop sharing your screen?
Yes, of course.
I would like to thank once again our speakers. You did do an excellent job. So Paul, Stacey, Marco, Theo, and Harris, thanks a lot. Before we close, I would like to give the word back to Jacopo Mancini from FAO. I also saw that he responded in the chat box about a company starting up in Africa. Maybe he wants to say something about that, but also I would like to give the word back to Jacopo for closure of this meeting.
Thank you very much, Leo. Thank you very much to all the panelists and colleagues for joining us for this third e-meeting, e-dialogue. Yes, we, as you know, I mean, to develop our study, we have interviewed companies and associations all over the world, and we are very happy to see that basically it's not just in in the Americas and Europe, though the majority of companies are there, but we see also a growing number of companies in East Europe, in Africa, not only North Africa. We have well-established companies in Egypt, but we are also seeing a growing number of companies. We have an association that formed in Africa, that is the African Vertical Farm Association, which are all good seeds to see that there is interest and willingness to engage in this, let's say, a third or fourth, I don't know, honestly, agricultural revolution. From our side, what we see is that differently from other revolutions, these may have a multitude of impacts on the short term and into sectors that are not usually those linked to agriculture, including real estate, including construction, and of course the well-known tech environment that is now leading every aspect of our life. I wish we had more time, because I would have loved to discuss also on the impact of energy cost and the current energy crisis on this type of companies. But just to say that from our initial analysis, what we see is that those that played sustainable since the beginning are potentially in a better situation, while those that played like business as usual energivory approach are now probably paying much more money and therefore having higher costs. But we do not have time to this. We will approach this in another e-dialogue. Please stay tuned to our communications and messages. This meeting has been recorded, like the other ones will be shared via email as soon as we close this e-dialogue, and it will be uploaded in our YouTube webpage, where you can also find the previous two e-dialogues. Feel free to also leave comments in there, and we will try to answer. By this, I think we reached 3:30 for the first time on time. That's good. I would really like to thank everybody, especially Leo, Paul, Ying, Stacy, Marco, Theo, and Harris for their great support and participation. And of course, all the colleagues, including Amara, that have been dealing with all of us. And of course, sorry, I forgot Marco. Apologies, Marco. So excellent. Again, many thanks. You have all our contacts. Feel free to reach us any moment with any sort of questions. Leo, have I forgotten anything?
I don't think so. I think you were quite complete. So thanks a lot.
Right. Thank you, colleagues, and have a nice end of the day. Bye.
Thanks,
Thank you
everyone.
all.
Bye-bye.
Thank you.
Thanks a
Bye.
lot.
Bye.
Bye, Farkat. Cheers.
Bye-bye. Thank you. Bye-bye.
Bye. Bye-bye. Leo, I'll give you a call immediately, okay?
Yes, that's good.
Yeah, because we need to talk about one administrative things. All right,
Okay.
thank you. Bye-bye.
Bye.